Okay, so in the previous lecture slides, you were able to know the term catabolism, and I hope that some of the very slight or layman difference, maybe you are able to get what is the difference between the catabolism and anabolism. But before this, we are going to discuss, or next thing is that first of all, we will go for the classification of organisms, right? So I would like to ask Alize, if you can just, Alize, reflect that what kind of organism classification you have seen and what was the major difference in them. Can you name that one?
Um, if I'm just talking about like the breakdown of food, then I would go like autotrophs and heterotrophs. And
Hmm.
basically, autotrophs are those organisms that use carbon dioxide as their sole source of like providing food for themselves. And
Hmm.
heterotrophs basically are forms that use other energy sources, like eating maybe like plants or something, and then they make their own food from that.
Okay, very good. Right, right, right. So, firstly, we have established that all organisms, on the basis of their food, right? So they have classified as autotrophs and heterotrophs. So now I am further expanding that concept that all organisms can classified on the basis of the two key things which are involved in bioenergetics and biomolecular, in your biochemistry and cellular metabolism for your food and how energy you are using. So this is the energy and the carbon, right? So firstly, the thing is this one, that what energy source the organisms are using and how they are taking up that energy and they are utilizing this energy to conduct their work or to perform their work, right? So if the organisms are directly taking up the sunlight as their key or the sole source of energy and they are performing their metabolic activities by utilizing the sunlight like the plants, so these are the phototrophs, right? The next classification is, what if they are not consuming the sunlight directly? So what they are doing, that they are not picking up that sunlight to perform their activity. They are basically utilizing the organic compounds. They are utilizing the food. They are taking up that energy, and that chemical energy will be converted to the energy which is responsible for carrying out their metabolic activities and their other physical activities, right? So if they are not consuming the sunlight directly as their sole source of the energy, so these are the chemotrophs, because they are converting the food material into utilizable energy for conducting their biological activities. So these are termed as the chemotrophs, right? Then the chemotrophs are further subdivided into the lithotrophs and organotrophs. So lithotrophs are those organisms which are mainly consuming the inorganic stuff, or inorganic material or the sources for converting that chemical energy into their consumable or usable energy. So they are called lithotrophs. Other one is the organotrophs, and we are kind of that organotrophs, right? So we are mainly dependent on the organic food, organic material, and then we are converting it into or usable energy stuff. So that is the classification on the basis of the first key thing, that is the energy. The next second key thing is the carbon, because we all know that we all are made up of mainly the carbon as the major element, as the major atom, or as the major entity, and then we are specialized by the combination of different atoms with that carbon. So as what source they are taking up for the carbon, in their, for their structure, for their metabolic activities, for their biological activities. So if they are consuming the environment carbon dioxide as a sole source for their food production and for their growth, so they are autotrophs. right? As the basic classification just Elise has mentioned, right? So next is, if we are not taking up that carbon dioxide directly and we are not able to fix that carbon dioxide into a usable material, so the other are dependent on the food, and that food will be that we are consuming autotrophs directly or some other stuff, and they are utilizing that food as a source of the carbon, right? So they are the heterotrophs. And then this is the phototrophs, further classified if they are utilizing carbon dioxide as their key source of the carbon. So they are the phototrophs and the phototropic heterotrophs, right? And then if they are consuming the food, so they are the phototropic heterotrophs. Now, the next was, if the chemotrophs are there and they are using carbon dioxide and they are fixing that carbon dioxide and they are converting it into their usable products, so they are the chemotropic autotrophs. And the next one is similarly, as we have discussed with the phototrophs, if they are dependent on the food and they are converting that food material into their usable energy, so then they are the chemotropic heterotrophs, right? So is that classification is clear to everyone, or do you have any question here?
No, ma'am.
Okay,
No, ma'am.
okay, thank you. So the next one is we were talking about the one thing is established, that what are the organism and how they are proceeding, how they are you taking up that food. So we have established the classification. Now on the classification and organisms base, they are the metabolic activities, they are the cellular activities we will discuss. So concentrating mainly on the human, so we will talk about mainly about the human. So how what kind of metabolic or cellular activities they have and how they are utilizing that food. They are breaking down into simpler one, or they are converting from simpler to the more complex one, right? So the first thing we have established, that all type of metabolism activities are having the two are divided into the two classification. One is the anabolism and other one is the catabolism. So Ikra, can you just elaborate what the metabolism term refer to?
Ma'am, metabolism is the combination of catabolism and anabolism.
Ikra, sorry, I can't hear you. एक तो आहिस्ता बोले और थोड़ा slow बोले.
Ma'am, metabolism is the combination of catabolism and anabolism, where there is a synthesis of something else and there is a breakdown happen later on.
Mm-hmm. Okay, very good. So this is a very much technical definition you have explained. So Amoon, can you elaborate in a layman term that what metabolism is in a more easy language?
Ma'am, it's a chemical reactions that break down the food to provide energy.
Hmm. Okay, okay. So somehow, okay, right. So metabolism is basically the summation of all or the steps all involved in either breaking down or either to form the new compounds which our body require, right? So for the catabolism, the important thing is this one, that why the biomolecules are going through some of the reactions, how they are proceeding. So this all is dependent on the energy. What we usually maybe have the concept that the energy or the kinetics or the thermodynamics is only involved maybe in the dynamic lab experiments. So there is no role of these thermodynamics or kinetics into the biology or in our biological system. So that is totally wrong, because thermodynamic and thermokinetics are too much important, and they are equally important for running and for making up of or usable components, generating these one, or breaking down the food, complex food stuff into the simpler units which our body can recognize and that can accept, right? So that's why we have to talk about some of the energy terms, and because we are taking up these energy terms into our further discussions when we'll talk about the molecular structures, when we talk about the catabolic reaction pathways and different cycles, right? So the first thing, as a chemistry students or the biological students, you may familiar with the Gibbs free energy equation. I know most of us are very much afraid of the physical chemistry. I don't know why, but the physical chemistry is basically explaining these phenomena, what is happening, and the stability and the you can say the availability or its ease, convenience of reaction through the physical chemistry, that either that is kinetically favorable or either that is thermodynamically favorable, right? So the first thing, you may are familiar with your basic chemistry courses, that there is a very famous equation and very famous term, that is a Gibbs free energy equation, right? So this is a G is equal to delta H or H minus TS. So this equation basically connect three thermodynamic parameters. First thing is the free energy, G, H is the enthalpy, and S is the entropy. This equation states that the free energy of a system equals the enthalpy minus the product between entropy and the temperature. So I think that is a straightforward. We will explain that what the meaning of that mathematical expression is, right? So G, firstly, you just remember that the G is the Gibbs free energy, H is enthalpy, T is the temperature, and it's power to raise to the entropy, S is the entropy. So anyone who can just tell me the synonym of entropy in your own understanding? Anyone? Hello? Hello?
यस मैम अब आ रही है आवाज
आपको कितनी देर पहले से आवाज नहीं आ रही है? Just let me know.
Ma'am, like 8 minutes हुआ होगा maximum.
Okay. Then it's okay. Right. Okay, so my question was that anyone who can just explain the other synonym of the entropy? Or you can just explain that, what you understand with the entropy?
Ma'am, it's the disorderness that occurs in a reaction.
Yeah, disorderness was fine, but occur in a reaction is something which maybe just ruin or concept what we're trying to build, right? So the randomness, the spontaneousness, or you can say the disturbance. So this is basically the entropy, right? So the next thing is the enthalpy. Enthalpy is the total energy of the system, and this is the energy which is present in the bonds, right? And we know as we are familiar with the chemistry terms that different atoms are combining through the bonds and they are forming the compounds and the more complex structures, right? So okay, let me ask if I can ask someone of you is okay. Yeah. Zainab is there or okay, no, Zainab, yeah, you are there. So Zainab, can you just let me know that if we talk about the proteins, so what kind of different bonds are there? Are there any bonds?
Yes, ma'am. I guess there are peptide bonds between proteins.
Yeah, very good. So there are the peptide bonds which are joining different amino acids. So in chemistry terminology, what we call this peptide bond? on the basis of the functionality? Zoha, are you there?
Ma'am, I guess amide linkage.
Yes, this is amide linkage, right? So it means the bonds are there. So we can't say the biology is separate thing and the chemistry is separate thing, right? So these are the interconvertible, or these are just going side by side. So the energy of the system, energy in the bonds are basically the enthalpy. So we will see, this is a molecule, and you can refer to the structure of the compound, right? So anyone who can guess that structure, if any idea about that one? Otherwise, nothing to worry. Okay. So enthalpy is the total energy of your system. In the case of a biochemical reaction, it includes all the energy stored in the chemical bond of all the molecules involved in the reaction, as well as the environment around the reaction, right? So this is the total energy of the system, bonds, what they are doing through, or they are going through certain kind of chemical reactions, cleavage, formation, and something, right? And then the environment, either they are taking up the energy or in the form of the thermal, or they are giving back to the system, right? So this was about enthalpy, H. And the next is, we'll talk about the temperature into entropy in that equation, what that exactly mean is. So the what is the meaning of the temperature times entropy Ts is G is equal to H minus Ts. So what is happening here? So these are the molecules which are well arranged, right? And after some of when if we are heating that one, so what they are doing, that they are having the more collision, they have the more power energy to collide with each other. So definitely they are increasing the entropy of the system, right? So what we know from the S is the entropy is a quantitative expression for the randomness of the system. T is the temperature expressed in degree Kelvin, and the T amplifies the entropy term of the equation, because raising the temperature intensifies the random molecular motion. I hope that make clear, because when we are suppressing, when we lowering the temperature, even if you just take an example of the gas, if you're pressurizing the gas, so you are settling down, you're arranging these molecules which were quite distant from each other, right? And they were having the higher collision power. So when we pressurize that gas, so we are arranging that one. We are lowering the entropy, but it needs some of the power. And once if we are giving the heat to that one, so they will again disperse. So it means they are raising that entropy, and there is an increase in the temperature that is giving the energy to the individual molecules to collide, right? To increase the randomness. So here you can see the free energy is basically the portion of the energy that is usable energy, or that is performing the work, right? H is the all energy, then minus what the temperature was and what was the randomness, because randomness is basically which is just increasing the entropy, which is creating the disturbance and the waste of that energy. So that after minus subtracting that value from the total energy, we get the usable energy, and that usable energy is basically the Gibbs free energy, right? So here you can compare the both of the vessels, as I have just given you the example of the pressurized gas, and then if you just pull out that lid of that container, so the gas molecules will again disperse, right? So what is happening in the both of these cases is we are pressurizing this gas to arrange that one. So here the Gibbs free energy is high. If we are just putting that lid off and they are just dispersing, so there is the low Gibbs free energy, because this is now a scattered one. This is not the arranged one, right? And the entropy is the high one. Make sense? So a system rich in free energy is unstable and spontaneously evolves towards a more stable state with lower free energy. So we have spontaneous and non-spontaneous reaction, right? So you see, we are moving forward from the energy, and now we are moving, ending at one level where we are establishing that what is the difference between the spontaneous and a non-spontaneous reaction, right? So you have gone through some of the term, the SN1, the SN2 terms in our organic chemistry courses. You know the term and exothermic and endothermic reactions, right? So there are certain reactions which are spontaneous, and some are the non-spontaneous. Non-spontaneous, which is slower one, right? And the spontaneous is referably towards the more its stable state, that this is the ideal. So they will definitely rush towards that there will be the spontaneity on that phenomena to gain that stable state, right? So the next is, what is the difference between the spontaneous and non-spontaneous reaction? So let me ask someone of you. Here is Noor Fatima. Noor, are you there?
Yes, ma'am.
Okay, Noor, I have a question that have you, do you know the Hammond postulate of the endothermic and exothermic reactions? Can you just highlight that one?
Ma'am, I don't remember it exactly right now.
And anyone who can just share his thought or her thought, just raise your hand, please, so I can ask to you. Anyone? I hope, Ikra, you should know. Or Elise?
I think it was something like the transition state had to resemble the reactant or the product, and that would determine which was more stable, I guess. Something
Yeah,
like that. I
yeah,
don't
exactly. That was the difference. That how much resemblance is between the reactant to that transition state. Either that is closer to the product, or either that is more closer to the reactant one, right? So on that basis, we were referring that reaction to the exothermic or endothermic reactions. Similarly, when we put that terminology in our bio terms, so this kind of reactions are either exergonic or endergonic, right? So the exergonic reactions are spontaneous, and from the previous slide, we have set up that concept or that fact that it has the lower free energy, right? So if you just compare this ladder, right? For example, this blue line here, this is a product one, and these are basically the your starting material, right, or your reactant one. So high potential energy of your starting material and or the substrate, because right now we are not using the starting material, so we will refer to the more biological term. So the receptor, or you can say the reactant, and then it is converting into the product one. So if the reactant is converting into the product by lowering its energy, it is at high potential energy, but it has to be at a lower level to be a product one. So this is a spontaneous one because it is sufficient enough and it can just release that energy and that can convert it into the product. So this is not looking for any external energy aid to convert from the reactant to the product one. Make sense, right? So if that energy which will be released, so it has the minus value. If your reactants are releasing the energy to convert into the product, so delta G is less than 0, and this is with the negative sign, right? So a spontaneous biochemical reaction is characterized by a decrease of the free energy, which is on this diagram, the difference between the high and the low potential energy, right? So this is the exergonic reaction in biochemical reactions. So the next is just the reverse of it. So we will see what is happening in that case. So this is the non-spontaneous. This is endergonic reaction. So your reactants are converting into the product, but now what they have to do is that they are not sufficient enough. So they have to gain some of the potential energy, and then they will be able to convert into the product one. So obviously, then this free energy has the greater value than the 0 1. So this is the higher one, right? So that's why if the free energy or the energy, workable energy, or the energy which is required to perform its function, so this is higher. So it means this is the non-spontaneous reaction. So this is just an example that how much sufficient you are, or if you have to borrow something. So definitely there is a latency, there is a delay if you are dependent on something, right? So delta G is positive for endergonic reaction, because now the reactants or the substrate is basically taking or utilizing or adding that potential energy to convert into the product one. Now, another thing you maybe have in your mind, that why we are only talking about the potential energy, not the kinetic energy. So basically, when we talk about the biomolecules, so you know, these are having a structure, they have their own shape. So they are not the individual molecules that they will just strike and they will convert it to the product. This is not the lab experiment. So this is having an optimal pH. There are so many other organs, there are so many other products, they are the minerals, they are the nutrients, there is certain pH. So they have to take up that energy and have to store that as a potential energy, and then they will utilize it according to either to conduct any of the catalytic enzymatic activities, they have to break down, or they have to form the complex molecules, right? So the next is, there are three other features that characterize the biochemical reactions. So spontaneous or not, that we already have established today. The next is the equilibrium constant. The other one is the directionality of the reaction, that either that is reversible, irreversible, it is moving forward or the backward, and the velocity of the reaction. So obviously the rate of the reaction, right? So that was basically for or today's discussion. Maybe the slides looks you the simpler one, but I will just shortly share some of the questions. These are graded like quiz, right? Or you can say the class activity. So you have to attempt that one, what you have here so far. So I just want to make sure that you got that concept rightly. So if you have question regarding this, so just let me know.